Synchronization method. One solution, it is declare the operation in a class bank as being synchronized. Synchronized public void credit account the account int amount in balance is equal to the account dot get balance. Balance is equal to balance plus amount. Update the balance. The account dot set balance of balance. Put it back in the bank. Synchronized public void debit account the account int amount. It's same as the above except for balance is equal to balance minus amount. Synchronizing blocks of code. It specifies a block of statement in the program as synchronized. Synchronized my object statement is synchronized with respect to my object. Any other statements in the program that are synchronized with my object that cannot be executed while the above statements are executing. Other solution, declare the code in the methods that is to be synchronized. Public void credit account the account int amount. Synchronized the account int balance is equal to the account dot get balance. Public void debit account the account int amount. Synchronized the account int balance is equal to the account dot get balance. Handling multiple accounts. Bank synchronization B handles multiple accounts. Had we left the synchronization of the method rather than the block of code, no debit operation of any kind would have been able to be carried out while a credit operation is in progress, and vice versa. Synchronization of a block of code prevents overlapping of operations on the same account, and that is what we want. Thread organization. The possible organization of a threads. Dispatcher worker model. An ideal worker thread is chosen by the dispatcher thread for the incoming job. T model. Each thread works on its own request. Pipeline model. Threads cooperate with each other in a sequential fashion. So this is the figure. A, the request for work arrives. B, also request for work arrives. C, also request for work arrives. And dispatcher method, dispatcher thread. This one is the worker thread. Here, three organization of a thread in the process. A is a dispatcher worker model. B is a team model. Okay, B is a team model. C is a pipeline model. Flickering. Flickering invariably occurs with animation. The reason behind flickering is the way Java paints and repaints each single frame of the applet. It is a calling repaint results in a call to update, which in turn results in a call to paint. Flickering is caused by update. Update and flickering. Update performs two functions. It fits the screen with the current background color of the alphabet. This is what is normally termed as clearing the screen. It calls paint, which then draws the content of the current frame onto the screen. Flickering is a result of the quick alternation between the above two functions. Quick alteration of functions. The quick alteration of parts of the frame that do not change between clearing the screen and drawing the current contents of the frame will cause flickering. Nations, what we see in quick successions of the screen background, color and the current contents of the frame being displayed several times per second. Avoiding flickering. The major two ways of avoiding, that is reducing flickering Java applets, are overriding update, so as not to clear the screen at all, or to clear only the parts of the screen that have been changed since the last alteration. Double buffering, which is achieved by overriding both update and paint. It consists in drawing the current contents on a graphic surface that is not on the applet screen and then copying the surface on the applet screen. Overriding update. Update is a method in the component class recall that update, it clears the screen and calls paint. To avoid clearing the screen, we simply override update by adding update to the flickering program, in which we only have to call to paint. Thus, the clearing task of the original update is eliminated. Overriding update continuation. Thus, instead of update method of component in which we have public void update graphics G, it's a code for clearing the screen. Paint G, graphic G, double flickering buffering. Double buffering consists creating a second surface on off-screen buffer on which we perform all the drawing and clearing, and then the contents of the off-screen buffer are transferred, deleted, bit block transferred onto the applet's surface. It is called a double buffering because we are switching between two drawing buffers. 5 steps of double buffering. 5 steps of double buffering are: 1. Create an off-screen buffer by declaring an image object, that is off-screen image, to hold the image, and a graphics object, that is off-screen graphics, to hold the graphics context. Create an image and the graphics context for the off-screen buffer. It is usually done by overriding initialization. Third point, perform all the painting on the off-screen buffer instead of the applet surface. Instead of the main graphics buffer, it is usually done by the overriding paint. Copy the contents of the off-screen buffer to the applet's surface. Use dispose to clean the graphics context that was created for the off-screen buffer. It is usually done by overriding destroy. Public void destroy. Off-screen graphics does dispose function. Exception. An exception is an event that occurs during the execution of a program that prevents the continuation of the normal flow of instructions. The purpose of exception handling is to make it possible for the program to either attempt to recover from the problem or at worst shut down the program in a graceful manner whenever an exception occurs. The program contains code which attempts to divide it by 0 or try to access an array element by using an index that is too small or too large. These are runtime exceptions. Common terminology states that when this happens, the system throws an exception. If an exception is not caught, runtime error that may be occur. Advantages of exception handling: it's separating error handling code from regular code. Logical flow of program gets lost due to the cluttering of the modified program. Propagating errors up call start. Propagate notification up to calling method. Grouping error types and error differentiation. Who throws exception? Java provides the capability to detect and handle exceptions. The exception that can be thrown either by the system or by code created by the programmer. There is a long list of exceptions called checked exceptions which will be thrown automatically by the Java system. The class thrownable. When an exception condition causes an exception to be thrown, that exception is an object derived either directly or indirectly from the class throwable. The interpreter and many different methods in many different classes throw exceptions and errors. Errors and exceptions are subclasses of throwable.